Hi, this is Lucas, and this is my CA2 for SLFX, where we had to create a HLSL code for a depth of field, for a bloom filter, the time bloom filter, and the glow map filter. So I start by demonstrating my depth of field filter that I created in HLSL. So as you can see, this is the a blur depending on depth of field. So it'll change depending where is your focus. So now my focal plane is about in the middle between my near and far focal planes. So as you can see, the middle pod is in the focus, and if I start changing this focal plane closer to me, as you can see that near T pod is in the focus. Now the middle one is becoming in the focus, and the close one is getting blurry, and far is a little bit blurry. And if I go a bit further, the focus is getting on a far. Now it's getting in a far pod. So for more demonstration, I can show you what is actually happening with the why is the blur so strong? Because I have the blur scaler also applied to it. So as you can see, if I take this down, the blur become less strong. So let's say if I put it to 100 and start changing these focal planes, you can see that the blur is less strong and you cannot see it as much. So it's about you adjusting this and where it feels that is natural. So for more demonstration, if I go to the pass that is doing the blur, what is happening with the depth is that if I compile with the depth, this is what I'm getting as a depth from camera. So it goes from 0 to 1. As you can see, closer is getting darker. And this is after I run it through the depth of field after focal plane. So if I compile it, it flips it. So 1 is close to me and 0 is far away from me. So if I start moving it now, if I start moving this focal plane and I go to the middle, as you can see, it's coming in focus, and now it's about in the middle. So as you can see that the color is changing from going from black to kind of like silver color. Then it's going to the totally white. So this is the focal planes are changing. So what is actually happening? This blur is based of a Quasant disk. So let me move this aside. So this is the 12 sampling offsets of a Quasant disk that I chose, and this is the offset weights. So the further away from a center the weight is, the less it will contribute to the blur, and then is the sum of all the weights. So what is happening? I run it through the blur scaler based of a depth. So I pass depth into this function, and it will give me if the depth is less than a focus, it gives me a scale between -1 and 0, or otherwise it gives me from 0 to 1. Then I need to put it into range between 0 and 1, and or 1 and 0. As you could see, it was going from white to black. And then I have my circle of confusion, which is where is the what is the camera lens basically, and I'm getting the maximal focus multiplied by depth after the focal planes, and this is my circle of confusion. So if the depth after focal planes is 0, that means that the circle of confusion is 0. If it's 1, that means that it's the maximum. And then what is happening, I'm going to blur the image based of I take the sampling offset, multiply by the pixel offset, and multiply by circle of confusion. And then I added some blur scaler so you can actually see the blur, because it was really small if I leave it out. and then I get the average color for each pixel and divide it by weighted sum +1 because I'm sampling the middle pixel right here, and then I spit out the average color. So there is more blur scaler added to it, the more blurry the image is. And then if I move this, as you can see, it's becoming in focus and then it's moving further away. So this is all for the depth of field. And the next one I'm going to talk about the bloom filter. So here I loaded the adaptive bloom filter, and as you can see, I have here the 1:1 render target, which is the average luminance in a scene that was downsized to 1/16 of the original size. Or I have my luminance threshold, which I can change right here. So you can see that nothing is blooming at the moment, and then the most white color is starting to bloom, and as I drag the threshold, more and more colors are getting into the bloom, and the darkest color come to the bloom the last. As you can see, everything is blooming around the darkest colors, and at the end I have an entire scene bloomed. So if I leave it like this and then I use the adaptive luminance, so this is the one that is calculated. As I move the camera, as you can see, it's adapting depending on how much light is in the scene. Here is kind of a lot of light. So this is the pixel that is changing depending on how much of a luminance is in a scene. And then I can swap this boolean and put it back to the luminance threshold, and I can just drag it where I like it. So how is it working? So I'm just gonna go through that real fast here. So this is all the passes that I needed, and on the left side right here are the render targets. So I have the bilinear downsample, which is going to be downsampled to 1/4 and then 1/16 of the original size. And then I have the I'm getting the 1:1 luminance, and then I'm going to use the Cavasi filter to smooth the. As you can see right here, I'm using the Cavasi filter, and it's getting the bloom. It's more and more blurry which pixels are bloomed. So I also use this variable which you can adjust right here, which is the Cavasi threshold. So you can just drag this more up if you want it to be more blurry, as you can see, or down if you want it to be like really sharp and less blurry. So this is basically doing just that. So what is happening if I go over the passes that I created? So first of all, I have a lot of render targets that are not totally required, but I like to see on my left side what was happening here. So I can see this, for example, is my grayscale luminance, which is not required at all. And also for the Cavasi, I have all 3 passes of Cavasi filter which are not required. I could just ping pong between the 2 Cavasi filter, which I'm aware that will be sufficient as well. So if I'm going down to my bilinear downscale, so I'm just looping through the 4 pixels around the original pixel. I'm getting the average of it, and then I'm passing it into the render target, which is right here. This is the 132. This is the 1/4 of the original image, and this is the 33/35, which is 1/16 of original image. Then after that, I'm getting a downsized image, which is that 1/16, and I'm getting a 1:1 render target, which is the adapted luminance, and I'm passing it into 1 by 1 pixel render target. And also I'm looping through all of the pixels to get the average luminance right here. Then I'm going to go to pass 3, which is the bright pass. So what I'm doing in the bright pass, I'm getting, this is just a boolean if it's true or false, if I'm using the adaptive luminance from this 1 by 1 pixel or not. If not, then I have the luminance and a luminance threshold, which is right here. It's between 0 and 1. And if the luminance is greater, it's going to be passed. And I could change this if I would want to get more effective luminance. I could change this to be white color, because now it's passing the color of the pixel. But if I compile with white color, as you can see, it's getting more bright. So you could choose what you need for your effect. And then just that for me, for my visualization, I passed a grayscale luminance right here, so I could imagine how which ones are more luminant in the grayscale values. Then in a pass 4, 5, and 6, I'm using the Cavasi pass, which is just I'm getting a blurrier image right here. So I'm passing this texture, which is after bright pass, and then I'm using that Cavasi filter and blurring it more and more with each pass. And what this Cavasi filter doing is basically I'm getting the half pixel size and adding into the U and V values, and then getting the top left pixel, top right pixel. So basically each pass I'm passing an iteration, and I multiply by pixel size, I multiply by iteration. So if I have iteration 1, this is just the old pixel size, but if I have iteration 2, this is multiplying pixel size by 2. If I have iteration 3, it's multiplying by 3, so it's spreading the pixels, the corners, 4 corners, more and more apart. So it's getting more and more blurry, as you can see right here. And in my pass 7, I have using the tone mapping. So I'm getting the original color and a blurred color, and then I'm lerping between them. So I can go right here and I can change this. I have the control over exposure and over the gamma, and also I put myself a control over lerp of the original images. So if you can see, this is the Cavasi, just the blur, and this is the original image, and this is with a bloom applied to it through the lerp. And also I can adjust this exposure, so a lot of exposure or none, and I can adjust the gamma. So this is to adjust it to something that you really like. And then if you are happy with it, maybe a little bit more of the that is Cavasi threshold, as you can see. Maybe a little bit more of the exposure right here. And then I have the Vignette, which gives me black edges around the screen, so I can adjust that as well to get a desired effect. So this would be all for my adaptive bloom, and next I'm going to do the glow map and time bloom